Hey guys, here's day 3 of section 6.1 notes. We are still working with operations and functions. So yesterday, at the end of yesterday's notes, we saw composition of functions. So it's kind of like this weird notation where you have this open circle, so it looks like it's fog or golf, but really this is f of g of x. And I'm not a huge fan of this notation. I prefer the other notation, which means this. If you are asked to find f of g of x, then you are really being asked to find f of g of x. And it should literally feel like you're plugging one whole function into another function, okay? If you are asked to find g of f of x, then that is literally the same thing as being asked to find g of f of x. Okay, so I prefer this notation better because I feel like it's a little bit clearer as to what you're being asked to do. All right, so yesterday we saw this with numbers. So it was like f of g of 3 or g of f of -4. With numbers, you just literally start by plugging the inside number into that function, get a number, plug that number into the outside function. So if they ask you to do it with x, it can definitely be a little confusing at first, but once you get the hang of it, it's not that bad. It should literally feel like you're plugging one whole function into another function. All right, so guys, look at this. Let me give you an example. If I said, let f of x equal -3x plus 10, right? So function f, when you plug an x in, this is what happens. You're going to times that x by -3 and add 10. If I asked you to find f of 4, what would you do? You would plug 4 in for that x, multiply and add. Well, what if I asked you to find f of 2x? Remember, whatever is inside these parentheses is what you have to plug in for x in the actual function. So to find f of 2x, I have to plug 2 x's in for that x. So then it becomes -3 times, not x, I have to plug 2x in and then add 10. So the problem is you're still going to have an x in your answer because you had an x in your input. All right, so now just clean it up. What's -3 times 2x? -6x, and then bring down the plus 10. Then you would look to combine like terms, but I don't have any. So this is your answer for what you get when you plug 2 x's into function f. That is your answer. So again, instead of plugging in a number, you're going to be plugging in an algebraic expression. You're going to be plugging something with an x in. So that's exactly what today's problem should feel like when you're finding f of g of x or g of f of x. It should literally feel like you are plugging an entire function into another function. Okay, so today, instead of plugging in a number, you are going to plug in an algebraic expression, like 2x. You're going to be plugging in an actual algebraic expression instead of a just number. All right, and this is what today would feel like. It should feel something like this. So I'm going to start with some easy examples and then build towards the ones that require a little bit more work. All right, so let's look at this example. They give you two functions. They give you the function f of x, which is equal to 5x plus 7, and they give you function g of x that is equal to 4x. So these are two pretty simple functions. The easier these expressions are, then the easier it is to do this. So let's say they asked you to find f of g of x, right? That open circle does not mean to multiply. That open circle literally means to find f of g of x. Now remember, with these types of functions, you start from the inside and you work your way out. So guys, technically, the first thing you should do is take x and plug it into g. But guess what? X already lives inside of g. So this is g of x. G of x equals 4x. So that's what you're going to plug in for g of x. G of x is literally 4x. So what you're really being asked to find is f of 4x. You're taking the entire g of x function and you're plugging it into f. So now you're going to take 4 x's and plug them into function f. So go to function f and start rewriting him. 5 times x, but take x out, put 4 x's in because we're plugging 4 x's into function f. And then don't forget your plus 7. Okay, so now what is 5 times 4x? It's 20x. And then I still have plus 7. Then you would look to combine any like terms, but I don't. So this is a finished problem. F of g of x is equal to this expression. This is what happens when you take the g of x function and you plug it into the f function, okay? So again, that's what you just did. You just took the entire g of x function and you plugged it into function f, okay? All right, so again, the easier these expressions are, the easier this is to do. All right, now they're gonna ask you to find the reverse. They want you to find g of f of x. So that literally means to find g of f of x. So you start on the inside. First, they want you to plug x into f. But guys, guess what? X already got plugged into f. This is f of x right here. So you're going to take what f of x is as a whole. F of x is 5x plus 7. And that's what you're going to end up plugging in to function g. So we have to take the entire f of x function and plug it into the g function. So go to function g and start rewriting him. He starts with a 4. Take x out, put the entire f of x function in for that x. So instead of 4 times x, it's going to be 4 times 5x plus 7 goes in to function g. And now it's all about the cleanup. So I got to distribute 4, and I get 20x plus 28. Look to combine any like terms, but you don't have any. So this is your finished expression. This is what you get when you plug the f of x function into function g. So again, you're not just plugging in a number, you're plugging an algebraic expression in. You're plugging an entire f of x function into g. Or you're plugging an entire g of x function into f. That's what it should feel like. You're taking one of these rules and plugging it into the other. Then you're taking the other rule and plugging it into the other function, okay? All right, so again, that's probably as easy as these problems get because these are pretty easy functions to work with. Let's try a more difficult one. All right, ready? Look at this one. Now they say, let f of x equal x squared plus 3x, and let g of x equal x plus 5. Okay, so now we have a squared expression, so it gets a little bit more complicated. And notice this function has 2 x's in it, so you have to plug in for this x and that x. All right, look at the first one. They want you to find g of f of x. So what does that literally mean to do? It means to find g of f of x. Okay, so we start on the inside. First, we're going to plug x into f. But guess what? X already lives inside of f. This is f of x right here. Right here is what f of x is equal to. All right, so what you're really doing is taking this entire f of x function, which is x squared plus 3x, and you're plugging this entire function into the g of x function. So now we have to find g of this. So we need to plug this into function g. So go to function g. It starts with an x. Take x out. Plug all of this in for x. So x squared plus 3x goes in for x. And then we still have to add 5. Okay, so then when you do that, you would look to distribute, combining like terms, but guess what? X squared plus 3x plus 5, you don't have any like terms, and you have nothing to distribute or multiply, so this is it. You're just done. When you plug this expression into function g, there's nothing left for you to do. There's no cleanup. You're just done. That is your answer. So that's real easy, right? Okay, now let's try in the reverse. Let's find f of g of x. So this is f of g of x, right? So again, we start on the inside. X needs to get plugged into g. Guess what? X already got plugged into g. This is what g of x is equal to. It's equal to x plus 5. So really, x plus 5 is what g of x is equal to, right? All of this is g of x. So that's really f of x plus 5. That's what happens when x gets plugged into g. It's x plus 5. So what you're really doing at the end of the day is you're taking this entire g of x function, this x plus 5 expression, and you're going to plug it into function f. So go to function f, which is right here. Take x out and put x plus 5 in for him. So x comes out, x plus 5 goes in, and what was being done to that x? It was being squared. So now the x plus 5 is being squared. And then we still have to plus 3 And then instead of timesing it by x, x comes out and x plus 5 goes in. So now this one has a lot of cleanup. We got to clean all this up. Well, remember, in order to square this, I have to write it twice and FOIL it out because I can't distribute an exponent over addition. So x plus 5 squared literally means x plus 5 times x plus 5. All right, and then here I have to distribute my 3. So plus 3x and plus 15. All right, so let's FOIL this out and see what we get. So what's x times x? That's x squared. What's x times 5? That's 5x. What's 5 times x? 5x. And then what's 5 times 5? 25. So that's what I get when I FOIL this out and now bring down the plus 3x and the plus 15. And then you just go through and combine like terms. So x squared plus no other x squareds is x squared. 5x's plus 5x's is 10x's plus 3 more is 13x's. And then 25 plus 15 is 40. So plus 40. And that is your new answer to what f of g of x equaled. It equals this new expression. That's what happens when you take the entire g of x function and plug it into f. You get this new expression. Okay, so again, this one got to be a little bit harder because you had to FOIL, you had to distribute, and then you had all these like terms to combine. But if you stay organized and you stay step by step, you should be okay. All right, let's try one more example. Okay, this will be the hardest one. Okay, so look at function f. It's negative 2x squared minus 3x plus 7. And then look at h of x, 4x plus 3. So he doesn't look that bad. This one, he's a little bit bigger. We got a square, we got another x over here. That one's going to be a little bit harder to work with. But let's see what they want us to find. All right, they want us to find h of f of x. So that literally means to find h of f of x, right? So first, you have to plug x into f. But guess what? You already plugged x into f. It's this expression. This is what f of x is equal to. So f of x is literally this expression. So you're going to find h of negative 2x squared minus 3x plus 7. So we have to go to function h and plug all of this in for x. So here we go. Let's go to function h. It starts with a 4. Then we're going to take x out and we're going to plug all this in for x. So 4 times negative 2x squared minus 3x and then plus 7. And then don't forget, we still have the plus 3 on the end, right? This is 4 times what you plugged in for x, and then you still have to add 3. And now all we have to do is clean this up. So let's distribute our 4. So that's going to be negative 8x squared minus 12x plus 28, and then bring down the plus 3. And then you look to combine any like terms. Well, I have no other x squared, so that's going to be negative 8x squared minus 12x's. There's no other x's. And then 28 plus 3 is 31. And now that is your new expression for what you get when you find h of f of x. When you plug the whole f of x function into the h function, you get this new expression. All right, the last one's definitely going to be the hardest. So watch what they ask you to do here. Now they want you to find f of h of x. So that literally means to find f of h of x, okay? So we start on the inside. First, we plug x into h. But guess what? You already plugged x into h. H of x is this expression right here. So h of x is literally 4x plus 3. So now you have to find f of 4x plus 3, which means you have to go to function f and plug 4x plus 3 in. So go to function f and plug 4x plus 3 in for this x and plug 4x plus 3 in for that x. All right, so here we go. So go to f, start rewriting. It starts with a negative 2. Okay, then I have to times it by x, but I'm plugging 4x plus 3 in for x. And then it has to be squared like that x was squared. Okay, so that's negative 2 times what you've plugged in for x, and it's squared. All right, then we have to minus 3 times, not x anymore. What are you plugging in for x? 4x plus 3. And then we still have plus 7 on the end of the function f. So guys, we have to clean all this up to be done. So first of all, we never multiply before we square. So I have to square first. And the square is only on this parenthesis. So that's going to be negative 2 times, in order to square this, I have to write it twice. So 4x plus 3 times 4x plus 3, right? I can distribute this right now if I want to. So that's going to be negative 12x minus 9, and then bring down the plus 7. All right, so guys, before we can distribute the negative 2, we have to multiply. We have to, well, tell you the truth, it really wouldn't matter now if you wanted to distribute the negative 2 first. I'm going to FOIL this together first. Okay, but if you put negative 2 into one of these first and then took negative 8x minus 6 and times it with him, that would be fine too. But I'm going to FOIL this. So bring down your negative 2, and you'll multiply him with whatever you get from this. So what's 4x times 4x? 16x squared. What's 4x times 3? 12x. All right, what's 3x times 4? That's another 12x. I don't like the way that wrote. All right, and then 3 times 3 is 9. And then don't forget to bring down your minus 12x. And if you want to, negative 9 plus 7 is really negative 2 if you want to start combining as you go. All right, I have a little bit of OCD, so I like to combine these first before I distribute the negative 2. Make it smaller and easier to work with. So that's going to be 16x squared. 12x and 12x is really 24x's, and then bring down the plus 9. And then my minus 12x and my minus 2 just come along. All right, we should distribute our negative 2 now. So that's going to be negative 32x squared. That's going to be negative 48x, and then that's going to be minus 18. Negative 2 times positive 9. Bring down your minus 12x and your minus 2. Again, if you're wondering how I got them, they combined. And we just combine like terms one last time. So negative 32x squared is my only x squared term, so he'll stay the same. All right, I have negative 48x's, and I have negative 12 more. That's going to be negative 60x's. I have negative 18 minus 2 more is going to be negative 20. And now you're finally done. And that's your new expression for what you get when you plug the entire h of x function into f. That was a hard one because of all the foiling and distributing and combining like terms we had to do. All right, but they're not all this difficult. But the more steps you take and just stay organized and neat, the easier it will be and the less likely you are to make a mistake. All right, you're gonna have a homework tonight on this. And then we quiz on Thursday, okay? All right, let me know if you have any questions. I am here if you need anything. Just please reach out and text me. Good luck, guys.